Hi guys, welcome back to Begin to Code with Mark. Today we're going to continue working on our Tic Tac Toe app. I think that we should mostly finish the logic today behind having the computer program actually think about where it should be playing its square. So right now, if we just start it up, if you remember from the last video, it just randomly plays a square somewhere on the board. So what we need it to do is start to think about where it should be playing. Should it win? Should it defend? Or should it just go in another square? So we'll have a little bit of intelligence behind the program and start it to think through and give us a bit of a game. So that's what we're going to be doing today. Please code along with me if you're beginning to code, same as me. If you're a developer, then please watch it through and comment on what I should be doing and how I should be learning. But this is my solution for it, so let's begin to code. Okay, so we've come into our code behind the game, and I'm just scanning through what we can do. So we've left our button game click in a bit of a mess, so I think we're going to tidy that up a bit. Some of this commented code we can remove because we've pretty much handled that elsewhere. So let's just have a look through. So we call check win, then we call computer turn. If not, we go game tied. I think we need to break out some logic here, because one thing I noticed yesterday when we were testing is check win can be true, but then it goes on and computer plays its turn, where it should actually be the end of the game. So I think we need to break some things out here around check win and around if the game is tied. So I think we're going to put all of this into a bit of a bigger if statement. So what we're going to say is that if check win is equal to true, then the game is completed. So then it can run reset game. Then else if, and we're going to create a new event now, which is going to be called, let's call it check tied. So if check tied is equal to true, then it will also reset game. Else we will run computer turn. Okay, so we've got a couple of squiggly lines around check win and check tied. So check tied we haven't actually created it yet. Check win we have created, but it's giving us an error. So we need to think why it's giving us an error on check win. So where is check win? So check win is here. So check win, this is the thing. We've built a void on check win, so it doesn't return anything. But here we're saying we want it to see if check win is true. Therefore check win needs to return something to this if statement so this code can run. And you can see in the error what it's giving us, it cannot be applied of type void and a bool. It's looking for a boolean, and check win is not a boolean. So let's fix that. So this is a private void check win. Let's call this a private bool. Now that is going to be returning a boolean, a true or false statement. So let's create something to return. So let's call it bool win, and on definition it's going to be false. So we don't know if we've won anything or not. Now in our if statement we've got a few things here, right? So we've got all of this if statement is basically our win. So instead of calling reset game there, we can set win to equal true. Okay, now outside of our if statement, which finishes there, we should, and outside of our loop as well, we need to come right out of the loop which finishes there. We can line it up. So down here we can return win. So check win comes in. The first thing it does is it creates a boolean which by definition is false. So it's going to go through our for loop. If there's no winners, it's going to return win, and win is false, so check win hasn't happened, and our if statement is not true, so it will go on and check if tied or not. If it is true, our if statement is true, it will update win to true, it will return win, and then our code will jump in and run reset game. So that's tidied up check win. Now we're going to have a look at doing the same thing for check tied. Okay, so looking at check tied, it's a very similar function to the if statement that we've got here with the boolean logic that we've just applied to check win. So let's create our private bool, which is check tied. So check tied at the moment is going to have a problem, I think, because it's not returning anything. Everything needs to return a value. So the first thing we need to do is create our boolean. So we can call it boolean tied. That equals false, and we're going to return tied. Return tied. So now we've got no errors on check tied. Check tied is never going to be true at the moment. So how do we see if check tied is true? Well, we need to come into and run our if statement. So if count is 0, then we can go through and take check tied. So we can put now if count equals 0, the message box, the game is tied. We don't need to run reset game here. What we need to do is set tied to equal true. Now if tied equals true, we've updated, well, if the game is tied, we've updated tied to equal true. We're returning tied, it is true. So now else if check tied equals true, we reset game and we come out of our if statement and the game is over. So let's maybe test these two updates. We've got check win and check tied. Both should be running through these functions now, slightly different to how we had them before. So we can still put the X, the computer's putting the O. We've got a win here, let's win it. Player X has won. The computer hasn't gone and we're playing an X again. X and O. X. The player X has won. So let's see if we can generate a tied game here. Let's go. Player O has won. I should have blocked him. So that didn't appear to reset the game when the computer won there, or did I misclick the button? Let's see if we can get the computer to win again. Player O has won. Okay, right, so when player O is winning, that's not resetting the game. Okay, let's think about that. Well, yeah. So actually I can see why that is, because we run check win equals true reset game on the button click. So when we click the button, that's not true. The check tied isn't true. Then it goes and runs computer turn. So let's have a look in computer turn. Here we run the check win statement. So I think we need to tidy something up around this statement. So if we come into our box, so actually we can just put the same if on here, right? I think we can just take this if and put that there. So the computer is going to go, count goes to 0, then it goes and calls the check win function. If it's true, it resets game. Let's try and run again, see if the computer can win. I want to give it, come on, go in that box. I don't want to win. Player O has won and it's reset. Fantastic. Now let's try and generate a tied game. Oh, I wanted to go there. Let's see if we can get a tied game out of this. Okay. There's not nothing stopping it from winning. XO. XO. I'm still going to win. XO. I don't want to go down that corner. I don't want to go down that corner. But it can win. Alright, let's try and get this game to tie. Okay, finally managed to get the game is tied message come up, and we're going to click OK, and our game has reset. So, okay, and then you can get it 2 in a row quite easily. So then we can see the game is tied, OK, and we go back to reset. So we've got a tidy piece of logic there that we go through, and we're checking the wins, and we're checking if the game is tied through this if statement. Else it runs computer turn. Computer turn right now is the random number, just putting it in any box which is empty. So this is now the logic that we want to work on, and as I said in yesterday's video, what we want it to do is think about how it can win, how it can defend, or play basically a random empty box because the game is too early to either win or defend. So let's get on to that piece of code. Okay, so we really want to give our computer program a competitive nature to it. We don't want to take the easy route. So when we start the game, I think it should look for the center square. If the center square is free, it should take it. Otherwise, it can take any other square around it. So that's the first piece we're going to take. So when computer turn starts, at the start of the game, we know that there's only one other square which is going to be selected with an X on the board. So the count is going to be 8. So we can say that if count is equal to 8, then the computer turn, it needs to select, or it needs to see if the center square is free or not, and this convert this if, where we see if a random square is free, can actually be used up here. So what we can say, let's put the brackets on to open the if statement, that if play boxes, so center square is play box 4, so if 4 tag equals 0, then let's have it playing 4, that box. And so we can put in all of our same code here. We can put that in there. Now I've just copied that code, which has immediately made me think we're repeating something. Because we're repeating exactly the same code here, but we're hard coding in the number rather than passing in the variable, which already makes me think this we should now put to a function, and then we can call the function there passing in 4, and we can call the function here passing in tick box. So I think we'll get round to that. But anyway, if our count equals 8, then we want to select the square if we can. Otherwise, we will run our random. So we can here say else, and we can take our random code, which is all this piece, Just want to get to the end of the for loop, so it's there. That's actually in the wrong place. No, it's not. So if our count is 8, then take the center square, else we will take our random. But we do have a problem. The problem we've got is we are not taking anything on this if the center square isn't full. So I think we should come and also fix that. Okay, so I've had a look through. We're getting a bit messy with the code, but basically I've moved the else statement we just did into our first if statement. So if our count is 8, then we know that there's one other box on the board which has an X in it. So then we will look and say, if the center square equals 0, then the computer will play it, else it's going to play a completely random number or box. So this is if it's 8. It obviously can't win at 8, so we can take our if check win statement out of there, and that has handled the computer's first turn. So now we need to think about the computer's subsequent turns. Okay, so I started to have a little bit of play around computer turn because I felt it was starting to get a little bit confusing, and we were starting to get to the point where we were going to be repeating a bit more code. So I've tidied it up a little bit. It's along the same principles that we were running, but instead of sort of selecting the buttons inside all the if statements, I've created a new function called comp select. So what comp select does is it looks at win lines very similar to check win, where we look at win lines as well. So this jagged array, but in order to play the boxes. So what this does is you pass in I and j. So win lines we know is a jagged array, so it needs the 2 dimensions. It needs the combo select is I, and then the position in combo select is j. So which row and then which column is it going to pick to determine which of the 3 buttons in the line it's gonna take. So play square will return that digit, and then we go through our same code. So we minus off count because we're playing a go, and then play boxes gets updated to 0, the tag gets updated to 10, the square is enabled set to false, and check win, we check win. So comp select is now going to be able to call every time the computer turns. So we've got 2 instances right now where that's going. It's still if the count is 8, so we're still running if start of game check for center square, otherwise play empty square. So this is the code that we have so far. So the computer's only going to take its turn on its first go, but let's run our code and just check through our logic here. So if we take the center square, the computer is obviously going to take another square around it, but now it's still not taking anything because the count is only checking if count equals 8. If we don't take the center square, the computer is going to take, the program rather, is going to take the center square. So it's always going to select the center square. There's nothing random about that anymore. If we take the center square, then it's going to take a random cell around the center. So that is working well, and it's still checking if it... No, it doesn't check if it wins. Actually, it does now check if it wins. Sorry, because we took it out in the previous code on 8, but because it's now calling the comp select message, comp select always is going to check if it wins, because this is the one that we're always going to populate. We're always going to run when it's the computer's turn. So on computer turn now we've got it to basically start the game. So now if it's not an 8, then what does the computer, or what does the program rather, need to think about? It needs to think, can it win, or does it have to defend? So that's the next piece of this function that we'll build out. Okay, so I've created a couple of functions in computer turn function, which is comp win and comp defend. So it goes through them in that order. If it can win the game, it's going to win the game. Otherwise, it's going to roll on to comp defend, and it's going to see if we need to defend. So now, how does it think about having to win or lose? Let's start to think about that. So let's create, we need two functions, comp win and comp defend. So we'll create private void comp win, and we'll also create a private void which is going to be comp defend. Get it dead right, comp defend. Okay, so now if the program, I don't know why it didn't like that. If the program can win, how does it know if it can win or not? So, well, we need to think how win lines works, or how check win works. So check win, the program knows if a player has won if our total equals 3 or 30. And 3 is player X and 30 is the computer or the program. So if we think about all of this code, if the computer program could see that it was going to win, what would it need to check? It would need to check if the total somewhere in one of these win line combos equaled 20. So that's the piece that it needs to figure out. Then it needs to figure out from there which box it should play. So we start really with our for loop. Let's take the whole thing. Let's take all of our for loop, we'll copy that and put it into check win. So we still want to cycle through win lines, because every win combo we need to see what they sum up to. But our if statements, we're not checking if anything is 1 anymore. We only need to see if our total equals 20. So we will just check if our total equals 20. That means there's going to be 2 O's in a particular win combo with no X against it. So we need the program to find the empty square and play that. So let's take this out of the if for now. So that's where we stand. So we get to the point where if the total equals 20. Now what it needs to do is figure out between A, B and C, which is position 0, 1 and 2 of our array inside of our array, which box is the empty box. So we can do that through some if statements. So we can say that if our total minus C is equal to 10, then what does that mean? That means that if our total minus C is equal to 10, then that means that A or B has the hang on, let me think about this. If our total minus C equals 10, then it means that either A or B is empty, right? Because we've taken C away, which must have been equal to 10. Okay, that's correct. So if our total equals C, then we need to figure out that if A is equal to 10, right, then we know we need to play B. And so we will run comp. Now we can call comp select, and we're going to play I. So we're in our loop here, Okay, and I is the first piece, so we know we're going to play I, and then we're going to play B, which is tag 1. That's the middle, so we can play 1. And I think we need, I don't know if we need a break on there or not. I'm going to put a break in. So if total minus C equals 10 and A is not equal to 10, then we must be playing A. So in this one, it's else, and it's the same logic. So comp select is still selecting I, but now it needs to play box A, which is 0. It's column 1, so then it will play column 1. So that's if total minus C equals 10, then we're either finding out if A or B should be played. If the total is not equal, then C must be the empty box. So then else we will play comp select, but it's going to play column 2. So this one is going to, this first one, let's put the note inside so we know exactly which it's playing. So this is playing, let's say playing middle column, okay, which is B. This is playing A, so this is playing the left column, which is A, and this is playing the right column, which is C, so this is playing C. So now we can see in comp win it should be pulling through to play either B, A or C. That's the order we've written in. So comp defend needs to be something really quite similar to this, but instead of it looking for the total to equal 20, which would be its winning chance, it needs to see if total equals 2, which means X is going to be winning. So let's have a look at that now. Okay, so in comp defend I've taken the same code as in comp win, except we've changed it to start to look at the X's. So if there's 2 X's in a row, then the total of that win combo at this stage will be 2, and it needs to go through the same logic to find whether it's A, B or C that it should be playing. So if total minus C equals 1, then we know it's either A or B that it needs to play, else it needs to play C. So that is going to play and defend. So if we run our program now, it's going to take a random square, but it's not filling, it should be filling that one in. So let's try and see that. Okay, so on begin to code, you know, we have to try and debug our issues on the fly. So my error here, if you look at where I placed comp win and comp defend, and you've probably been watching the video screaming at me saying I've done it wrong, is I've still put it within my if it equals 8. That's the squiggly bracket where this if statement finishes. So comp win and comp defend don't play in that box, they play down here. So if it's not equal to 8, then it goes comp win, comp defend. So let's run and see if it's actually going to start playing through the game a little bit. So it's going to take the center. Now let me take a top row, and it should block me. It blocks me. Let me give it the win, and it took the win. So let's take the center, and it goes for a random. It's going to block me. Now this one's going to give me 2 options, I think, to win. So which one's it going to play? It's played one up there, but I can take the win. X, it's going to take an O, it's going to block me, it's going to block me. No one's going to win this. Game is tied, and we reset. And it's playing with some form of intelligence, and it's taken the win there. Now if we I really need to test this to see if all of our combinations, it seems to be playing quite well, but is there ever an instance where we don't equal 2 or 20? There might be. If I take it there and put it there, then that's the gap, which isn't a logical way, I guess, for me to play. But here we don't have, we've played two X's and we don't have a win lines win combo summing to at least 2. Win combos 1 and 4, and whichever this diagonal is, either 7 or 8, is going to equal 1, and win combos, definitely, I think that's 2, 3, 4, 5, 6, is going to equal to 1. But it's not finding, in this instance, how to play, and it's definitely the computer's go, because I can put another X in now and take the win. So that's a little bit of a logic in the game we need to figure out. So we've got our check win, we've got our check defend, but if it can't win and can't defend and the count is not equal to 8, it still needs to play another random square. So let's think about that one now. So comp win has failed, comp defend has failed, so let's write in an if we cannot win, defend, or if we cannot win or defend, and count is not 8, then it needs to play another square. Okay, so in this instance, how will it know this? So if it's going to be the count, if the count is going to be equal, if I've gone twice and it's gone once, then the count is going to be 6. I don't know if we can go any more below 6. Well, it would be another 2, right? So it would be 4. I don't think it can probably go below that before we have at least a combo. So let's say if count is 6 or count is 4 and comp win and comp defend haven't been triggered, I think it's probably possible on 4, then it needs to play another square. Okay, so then let's call that comp play another, and this is going to be some sort of random, right? And so we have our random up here. It's going to be this code, I think. We'll call from comp play another. Comp play another will call comp select, because we always are playing through comp select. So we have our comp win, we have our comp defend. Let's put it here. So this is going to be a private void comp play another. And at least we have a bit of logic in our code now. It goes win, defend, another, it goes into select, all from our computer turn. So we will tidy this piece up later. So comp play another needs to take our for loop. It needs to take our random and our for loop. It needs to take this. Comp play another. So comp play another will take a random. It'll take the 2 because we're checking it through comp select looks at win lines, right, to find the play square that it should be taking. Else it does that and it goes through comp select goes through, checks wins. Let's play our game and try and trigger our scenario. So if we put an X and an O and an X on another line, no, that's overwritten an O, which it shouldn't have done. That shouldn't have been playable. And O has won. Well, yeah, but O cheated. X and O, X, and it's taking that square every time. That's taking that square. Maybe we've got. It's defending and winning. Okay. Maybe we've got. Right, that took a random square and created a nearly winning combination for it. Now it's blocking us off, but yeah, I'm not sure why it was taking that square. It's not doing it now. So I clicked off the game there. So let me try and debug why it was overwriting something which had been played in comp select another. That shouldn't be doing that. Okay, had a little bit of a look at the code to try and see what was happening, and here's the gap. We are selecting in comp play another, we are generating two random numbers, we're passing those to comp select. So if the tags on those don't equal 1, if random another 1 1, no, that's not going to work, is it? Because we're not actually looking at the tags on random another, we're just saying if random another doesn't equal 1 or 1, which is a random number. We need to, this is our gap, so we need to see if this win lines ij combination of the randoms that we're selecting, the tags don't equal 1 or 1, then we can play that square. So that's the gap that we need to build into this. So we're going to select our two random numbers. Let's try and write this out a bit of a longer way. So we need if what? If playbox is, I think we've written this code somewhere else, haven't we? Where did we already write this? Where did we already write this? We wrote this out, I'm sure of it. It's this. It's this piece, yeah. This is the piece we need in comp play another. Right, so so my code here is probably getting a little bit messy because I'm starting to copy and use the same code. It really does need to be done a bit more intelligently, which we will tidy up in the next video. So now we're not passing I, we need to pass I is here just to keep a loop going if another random 1 or 2 can't be played. So we're not passing in I, we're passing in another random 1. We need to pass in our combo and another random 2. So this is going to find the play boxes. This is going to identify the box. So if this all equals 0, then this box hasn't been played. Right? What doesn't it like here? I think I need some 1 2 1 2 1. I need another bracket somewhere here. Yeah. So if our random numbers haven't been picked, then it can play that box. So then it can select, comp select, and play that box, right? Else it needs to say I minus minus. It needs to try and find another one. I think that's correct. Let's run it and test it. It shouldn't play the box. It's XO. Well, it didn't take it that time. Game is tied. XO, 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 XO. The game is tied. It's not seemingly taking it anymore. It took its win. It's taking the center when it shouldn't. When it's free. It takes a win when it needs to. Did it have an option to defend there and didn't take it? Well, I have to look at the video, but I've got to win anyway. XO, XO. Blocked me. Seems to be working. XO, XO. So if it can win, it wins. And if it can defend, it can defend. Didn't go there. Ah! It didn't go there. That is that combination which I said probably wasn't going to work, but it does work. There is another combination. There is another combination where it cannot win or it cannot defend. Because you've got to think about where it's placing on the board. So it must be down to Compass 2. X, so we've got, it's playing its game. It took its win. It's going to be maybe quite hard to generate the same scenario again. It's going to take it, it's going to block it. Yeah. It seems now to be playing as we'd like it to play. Seems to be working. Probably needs quite a bit of testing here behind our logic, but it seems to be going. Now, one thing similar to the lottery app, it immediately plays it square. I'd like it to give the impression it's thinking about it. So what we can do after our turn is, what was it? It was system.threading.thread.sleep. We're going to sleep it before it goes through. I want it to have the impression that the program is thinking about where to go. And you can see it working through its logic and think where to go. I like that. Maybe the sleep is a little bit too long, so we can make it, let's make it 750. And also it sleeps before game tied, which is, well, let's just move it actually. Let's check win and check tied, else it's the computer's turn after we've slept. So now check tied should be running and check win should be running immediately. So it thinks where to go, it's thinking where to go, it plays it square, it blocks us, but check tied should come straight away. The game is tied. I think that came straight away. No, it didn't. I'll tell you why, because I've copied rather than cut. We'll take it out of there. Right, now it should be boom, X, boom, X, boom. Play O as 1, and that came straight away. O, X, O, X. Play O as 1. Game is tied. There we are. So it kind of gives the impression that it's considering where to play rather than immediately doing it, and you sort of don't maybe notice immediately where it plays. Now you can see for sure where it's gone. So we have our tic-tac-toe game playing against us as we planned, with some form of intelligence. It tries to win, it tries to defend, or it just plays the empty squares to keep the game going. So that's good. If you've played along, so this Boolean player true, we're not using that anymore, so we can take that one out. So yeah, I think there's quite a bit of tidy in the code to do, quite a bit of comments. But if you built it along with me, then have a read through and have a review of what you've done, because I think there is some logic here, although there is a bit too much repeated code. That's a problem, right? This piece of code we're repeating a few times. So we've got it in comp win, we've got the same logic in comp defend, we've got it in check win. So as soon as I see 3 pieces of exactly the same thing, then I start to question, why isn't it in a function and we're calling a function instead, right? Because if we have to change some logic here, we have to change it in 3 places, which just is going to be prone to errors. So that we need to think about, and we will do a review session of our tic-tac-toe game in the next video to keep it really tidy, to comment it, to create some regions in the code, to finish it off nicely. But tic-tac-toe is done. We have the working playing game. It tries to win, it defends. You can spend hours playing this, I'm sure, but I hope you're all happy with it. That's my solution for it. I think it looks good, I think it works well. So we will end the video here. So what are we going to do next? There's a few more videos coming up on the channel. We are going to do our review of tic-tac-toe, so our last video on this, tidying up the code, keeping it nice and tidy. Once that's all done, I might be able to put my code solution on GitHub for you to download at some stage. There's also going to be now a new project coming up. I think what I'm going to do is one of those matching games where you click on different squares and it reveals a picture and you have to match them. But that one's going to be, what I want to do with our projects is always bring us on a little bit forward, a step forward. So try and learn a bit more. So instead of having maybe a fixed grid, we can select, well, how difficult do we want it? So do we have 10 pictures or 20 pictures or 50 pictures, say, to choose and try and match? And so we try and generate different formats of the game, so there will be a bit more logic all the time added to our projects. So it's from the lottery app to the tic-tac-toe app, we've started to use a bit more logic. So for our next app, we're going to start to do a bit more. Another video that I'm planning to do as well is around job interviews for people who are beginning to code, because this is maybe a career that you want to get into. I want to show you for where I work what questions that we're asking people and how we test people. So I don't ask them, right, but I have developers at the company. They interview a lot of people, and so I'm going to give you a bit of an insight into the technical piece of the interview that candidates have to go through. And a lot of them have really experienced CVs and don't do very well. So I think that'll give you great insights into what hiring companies are looking for in 2021 for developers. So that's the end of this tic-tac-toe video today. Thanks everyone for watching. Like, comment and subscribe. I hope you're starting to enjoy Begin to Code. This is a new channel at the moment, but we've done a few videos. We've got a few more things coming, so let's keep going. Look forward to seeing you in the next video, but bye for now.